Hello, everybody. Thanks so much for joining. We are here to talk about how to inspire the next generation of embedded machine learning folks. So yay. If you have any questions, please post them in the chat and they will be relayed to our lovely panelists. So let's start by actually introducing ourselves. Like, why are we here? Who are we? So I'll start with myself. I'm going to be moderating the panel and probably chiming in because I have a lot of opinions. My name is Jen Fox. My pronouns are she, her. My current full-time job is as a senior program manager at Microsoft, where I'm helping to explore ways that Microsoft can support and engage makers. As part of that, we are looking at ways to make embedded machine learning more accessible to a broader swath of folks so that y'all can solve the problems that you are passionate about. All right, so I will pass it off to the person on my video screen left. Vijay, go ahead.
Hi, folks. It's good to be here. Thank you, Jen. My name is Vijay Janapareddy. I'm a faculty member at Harvard, and I'm extremely passionate about embedded machine learning because I honestly believe it's got the potential to change the world, which is why I'm excited to be on this panel. And I've done courses around TinyML and things like that I'm very excited about, like sharing with the broader community.
Whoops, I have a mute button that works for Teams, but not for Zoom. It's like, oh no, that's a different program. Awesome, thank you. I wanted to call you Professor. Thank you, Professor Vijay. Mike, I'm going to pick on you next.
All right. Thanks, Jen. I'm Mike Sinisi. I'm the executive editor for Make Magazine. And if you're not familiar with Make Magazine, we track all of the different stories and projects that the broad maker community are putting together based on all of the exciting different new technologies that are out in the world. And one of the newest and most advanced of these technologies at this point now is embedded ML. And so we have been following that one of late, and there's just so many exciting avenues that it is traveling along. I see one of our more recent issues even has a project by our fantastic host moderator in this issue. But I'm really excited to be part of this panel and be part of the event. It's been a really great event so far.
Yay! Thanks, Mike. Huge fan of Make, and probably a lot of people are also. All right, Eric, you're up.
Hi, thanks, Jane. Hi, everyone. This is Eric Pan from C Studio. Excuse me for the terrible background because it's midnight here in China and we're in a holiday. And I'm in the deep mountains of 3,500 meters. But I'm here because we cannot miss Aging Pulse. We cannot miss Imagine. Seed has been doing open source hardware for 13 years. We have been doing all kinds of microcontrollers, sensors. But now for the last few years, we realized that TinyML is becoming very exponential, and we become the early adopter of that. We make all kinds of stuff that are compatible with Aging Pulse. So I like to see what's happening next and inspire more people to join the community. Thanks.
Heck yeah, best of both worlds. On vacation, and we get to talk about EdgeML. Rad, awesome, thank you. Okay, so we are gonna start by talking about how do you see embedded ML impacting technology and society? So it's a pretty loose, casual panel. Feel free to jump in if you want to share something.
I think, okay, Vijay, go ahead.
Okay, so I'll start. I think like the reason one should be excited about embedded ML is, I think you got to look back on when we had some of the most exciting sort of changes in society with technology. I mean, if you go back to the original Apple I, for instance, or the Apple II, that machine, which was literally a workstation, right, had, I think, something like 4 kilobytes of RAM, a hard disk of about 80 megabytes, and a processor that was running at about maybe like, I don't know, 1 megahertz to 16 megahertz, something like that, right? If you even take the very simplest microcontroller today, it's far superior than that big workstation. And just imagine what they did back then with that very old computer. I mean, they changed the world, right? Steve Wozniak and all these guys just changed the world. And that's why I honestly think the computing system and the software that we have now for embedded systems reach this sort of like critical junction where I think we're going to have people coming up with experiences or use cases that you and I are not able to imagine, right? And that next generation, I think, could be a high school student or it could just be anyone. I think the technology is at this point now, if we can just get these students to understand, hey, there's this potential here, right? I bet you we're going to see a very different world than what you and I are possibly imagining.
Yeah, it was one of my notes that I was putting down for our talk is just the access that a massively distributed development force that is now available to a world like this because of the price points, because of the accessible tool chains that have come about, like Edge Impulse. It's hard to what directions this could all take, but there are certain things that we've seen already coming together, and then from here forward, it's really broad. It's really exciting.
Yeah, from my point of view, we see the AI has a lot of problems now. How to deploy? We are missing the last mile. So we have been looking at Edge AI, and we feel that it's not only the last mile; it's the last meter. Away from your computers, you can access to all the physical world. And we see also by enabling more people to either to use Edge AI or get trained on their own data set, we see much higher potentials because you all kinds of professionals, you don't need to be an AI experts or embedded experts. Now you can just pull out some devices, even without coding, you can do something. I think it's going to be revolutionary after many years. It's like after a few years, you can have R2D2 and just talk to it. The best coding is no coding, you just train it. So that's where we see the passion.
Yeah, I love all of those responses. And to kind of bounce off of what Eric said, in my view, I'm really excited about, on anything that makes technology more accessible for more people to participate. We all walk around with a computer. Most of us walk around with a computer in our pockets. Not that many folks understand how it works and what its limitations are. So I view embedded ML as an opportunity for us to start talking about how do we build better systems to bring more people into the conversation and to tackle some of the current issues that we have with these very large AI models, right? Like where you have a very specific set of people that are making decisions and have some blind spots, and that's totally fine. But I would like to see more people in those conversations. How can we work with smaller data sets that we actually can understand and that we know what their limitations are, and how can we deploy those in smaller applications that will be more appropriate for the target audience. So yeah, I think it's a really exciting area to be in, and the tools are making it just you don't need a PhD in data science to get started, which is so exciting.
Yeah. I put down a couple of thoughts of some of what I thought of, actual technology society elements, like manufacturing and food and transportation and medical. I felt silly writing those down because I also felt like that's me applying like a really direct mindset of these are the things we need right now versus just leaving the space open for the creativity and the experimentation that I think that is now available in it. And so I think that, there are things that we know right now, but there's just so much more.
Totally. Yeah, I love that. I think one of the things I loved about teaching is like kids come up with the wildest ideas. Like I had a student that was like, I want a remote control robotic table. Okay, all right. So if you put the tools out there, if you make building custom machine learning data sets easier, who knows what folks are going to build, who knows what problems are going to solve. So yeah, totally. I feel you. We have things that we're each passionate about, but everybody has their own individual passion. And together, that's how we build better systems. Yay. So let's see. Why do y'all think someone should learn embedded ML for them?
I think that why is very critical, because I think the meaning is obvious. Everybody wants to have some AI, but they are kind of frightened out. And to me, I see that is with embedded AI, a lot of jobs, a lot of functions, the personal can have their productivity, and that can scale their productivity like never before. And it cannot be done by some like AI experts to guide them. It's going to be the real field operators. It's going to be the field experts pulling all resources towards that. And now it's the time. Everything is much easier. Every hardware, software, even the way you use AI is just by your hand. I think it's an opportunity for everyone, but who is going to turn it on first?
Yeah, that's real.
Yeah, absolutely. The opportunity aspect is something that I always find to be really interesting about what the maker community is doing. And make in a sense is a learning community. That's one of our biggest missions, is to encourage learning for everybody. But then what do you do with that? Where do you take it? And there's personal projects, and that's always satisfying and fun. But especially for some of the younger people in the community, there's also professional opportunities. And as Eric's putting it, we don't necessarily know what those are going to be just yet, but these are skill sets that absolutely have placement in a workforce, and that's going to grow in a gigantic way. We've got to program the machines and keep them running. So this is how we start getting there.
Yeah, totally. Someone's got to program the R2D2, or we'll never have one.
Yeah.
And it's
sorry, go on, Mike.
I was just going to say, R2D2, since it's come up twice already, I was looking up all of the mentions of AI and ML in Make magazines, and the earliest mention is Make Volume 2. There was an article about an R2D2 Builders Club, and that was the first reference of AI. But of course, and that's 2005. So that's 16 years ago. But AI and ML, like these concepts, they go back way earlier than that. So we didn't by no means coined the term, but it's been something that it's been a concept that we've been mentioning for quite some time. But sorry, go ahead, VJ. I stepped on you.
No worries. Appreciate it. I think I have a very different philosophy as to why one should learn embedded ML. And it's not about the technology. I think we're all excited about technology. We geek out. And yes, it's absolutely important. And double clicking on Mike's point that it is a great way to kind of bootstrap, a career pathway. But the most important reason, personally for me, is that we need to get every single student, every single child out there to really understand the power of the data that they're sitting on, the data that they create just by their actions. It is the richest commodity on this planet, and it will be the richest commodity as we go into the future. We can have all this stuff that we build, but if they don't understand the value of that data, I think we could lead into a society where people can be exploited, right? There's no equity in the system. Like, I think if they interact with it, often when I'm teaching this, I say, forget the ML part. Like, yeah, that's going to be a push button solution. There'll be a few engineers. Just how many of us write an operating system? Not many in the grand scheme, a handful of people, we like to geek out and we'll do that. But that's not really the thing, right? Like, it's the data that you actually need ultimately in the ML component. And I feel like if they play with the machine learning thing, and then we teach them how critical that data is, then I think we're really setting them up for understanding where the future's going, because then they can make the right choices, because there'll always be engineers who can build so forth and all that. But even if I'm not building the embedded ML thing, if you understand the value of data, then you will know how to guard it. You'll know how to protect it. You'll know how to appreciate it. Right? And so that's why I would say that people should really understand embedded ML as a means to get access to their data.
Yeah, go ahead.
I was going to say, that's a great point.
Yeah, absolutely. I think, I think that there are a variety of reasons that folks should learn embedded ML. And I love that we all kind of touched on something unique and individual based on our perspectives and what we value. It is a really great opportunity for a good job. And if someone wants to go into the field because there are lots of opportunities, you can work in lots of different cities with great companies and great benefits. That's totally valid reason to learn a skill set. If you want to build projects, also a totally valid reason to learn a skill set. And also, to Vijay's point, like, this technology is around us, and it's not going anywhere. And it's really important that we understand how it's being used. And kind of like what I was saying with smartphones, I think it's really important that we understand what these systems are and what their limitations are, how our data is being used, how it's not being used, what data is private, and how we can advocate for ourselves. And when we learn how these technologies work and how to build them, we start to understand how powerful they are and also what their limitations are, which I think is really important when we want to go and advocate for ourselves in terms of policy making. Awesome. Ooh, we have some questions coming in. All right. What are some considerations for model bias and data ownership? It's a great question.
I think whoever does the machine learning trainings, I think the ownership should be encouraged to who, like a lot of PGCs, which professionals generate their like data sets, which is totally unique, and you don't need to bother to do that. Because last week I was just visiting some civil engineers because they're trying to use machine learning for bridge health, because vibrations, the status of the bridge. But if I'm doing that, how can I get all the data? It's not going to happen. But if it's the civil engineer who owns the data, they have the simulation to do it and to share the data. Maybe it's free, maybe it's on a paid basis. But by any means, everybody can share that data sets, and suddenly they have the know-how of how to monitor a bridge. If I'm in a remote area, there's no like IBM helping me out. I can do that myself with the help of experts through the machine learning bridge.
Yeah, totally. I love that.
Just
anyone else want to chime in on model bias and data ownership? I touched on that a little bit, but that's one of the reasons why I think embedded ML is really important. Smaller models that you get to curate.
Yeah.
Mm-hmm.
What happens if a student doesn't want to learn code, but model training only? That's a great question.
Yeah, that's one that I think that's really interesting. I'm not a great coder. And I know that it's one of the important parts of having to getting involved in these technologies. I think that there are new code types that become easier to use, and I think that it's right now the way that I see it is eventually you have to jump in and figure some of it out. But I also expect that there will be more and more there'll be more and more new elements that come into place that start to eliminate the challenges that current coding presents. It makes it a lot easier and a lot smoother. It's daunting at the moment, at least from my perspective, but probably less so than even I'm allowing myself to realize.
Yeah.
But I do think from where I sit, we got to learn some of it.
Yeah, exactly. I totally agree with that. It's not their fault, and it's our fault that we haven't delivered a simple enough solution to that. In the end, they should be wait until like maybe the day after tomorrow. I'm an artist. I'm a great artist. I'm a great biologist. Why there is no good machine learning tools for me? So they should make the demand, and we should answer for it.
I'll just say that if you just wait a little bit longer, you'll have some embedded GPT-3 that basically writes it for you. You just tell it what you want, and it'll be like, "Yeah, I think I got. Yeah, let me go fix the model for you. Don't worry about coding. Just tell me what you want, and I'll synthesize it for you." I mean, why not? I totally would expect like the whole notion of training these models and so forth is gonna just like it's not something that everybody needs to learn. right? I think we're going to get to a point where, like, if you're talking about simple tasks, like, I mean, even think about like detecting keywords, right? There's already techniques of few-shot learning and so forth, where for someone to actually train a model to recognize a keyword, you don't have to train the model yourself, right? This is why you open up your phone and it says, can you read these words, a few times? What they're doing on-device fine-tuning, right? So you're effectively training a model. You have no idea that that's what you're doing. So I think that's the kind of technology that we're actually going to hands down see. I mean, my lab does this. There are plenty of research papers that are already doing this, right? So another 2 years, I really think for specialized domains, especially in embedded ML, I think there are going to be plenty of auto ML kind of tools that just out of the box will get you a trained model just by a few examples.
Yeah, totally. This question really resonates with me because even though I have a technical background, it's not in coding. And I didn't really care about coding until I found hardware. And then I was like, oh, I can use software to like build things that do stuff in the real world. Not that computers aren't, it's a different application. And for me, the thing that I was stoked about was getting a motor to move or getting a sensor to read something about the real world. And so to Mike's point, like, I feel you, Mike, like I'm not a great coder. I'm dangerous enough to like make it work. And then I like hand it off to my friends to be like, are there any security vulnerabilities in here? Is there anything that you would fix? That's also why I love open source, right? Just like, put it out there. If you want to make it better, make it better.
Absolutely.
Yeah, right. That said, it is really interesting because I do think we're starting to see some of those tools where you don't have to be a software engineer or an expert in code to be able to start to be a little bit dangerous with embedded ML. I would, we're here at the Edge Impulse Imagine conference. That's why Edge Impulse is super cool, right? Because it simplifies the training process significantly than just working directly with the TensorFlow code system. And shameless plug, my team has been working a lot with this program called Lobe.ai. And it's a free local code program where you just take pictures and you type in the label, and then it creates different categories for you. You can export in a variety of model formats like TensorFlow, but like if you get a sample program where you are basically just seeing how someone else took that TensorFlow model and shoved it into a code block, you can kind of just like, if you want to do that, all you really need to know is how to read code. And if someone comments their code properly, then like you should be okay. But these tools are coming out. They're mostly around image classification and object detection, but poke around with Edge Impulse, maybe try Lobe. Have fun.
Lobe is pretty fun.
Thank you. I really like it. And that's like, if I take off my Microsoft hat, like I really like it as just a maker. What are some potential risks you see specifically with embedded and tiny ML?
I sort of have a rather weird sort of twisted perspective on this, right? So when we think of like embedded ML, what's the key thing? By and large, I would say it's mostly about sensing, right? It's really about modalities of different kinds of sensors and the input that you're pulling in. I'm not worried about what the sensors are sensing as much because I think we focus on that. What I'm really worried about is the feedback loop that can get created where your sensors are no longer just passive, they're actually starting to be active. In other words, you can effectively manipulate a situation through, if your whole environment is kind of set up with sensors everywhere, right? Sensors that encourage you to stand up, like my watch tells me, oh, you should breathe. I don't know why it's telling me to breathe. What's going on with my body? I don't know, but I'm going to take another breath, right? Or it says stand. I don't know, it says stand. So I'll just stand. The point is like, they're becoming active sensors effectively, right? There's some sensing happening and it's coming back and it's influencing my behavior. How, why, I can't make all the connections, but that's exactly what a model will make connections on. So if someone crazily just saying this, right? If someone quote unquote hacks it, they could effectively get you to do things and you have no freaking clue what you're doing, why you're doing, but you're doing it. That is my biggest fear with embedded ML. Kind of paranoid.
I think it's just the beginning, and a lot of people are afraid of trusting the microcontrollers to do machine learning, and some might be brave enough, but it's not ready for real like critical missions yet. And it's a lot of field test, a lot of real project to get it going. So I feel if people don't understand that, just oh that's the remedy, and they are going to cause a lot of problems. I think the technology itself will be evolving accordingly.
Yeah, 100%. Yep, there is that risk of if it's just one person putting out a project, how do you know that it actually works? I would echo kind of, I think my biggest concern is privacy and security. And, I think that there are different types of risks, right? Like, I love the fact that I have more control over my data and I can choose to keep it local, and not even send it to, one of the big tech companies. That said, like, I think that there are security vulnerabilities that we aren't really talking about. Specifically, like, what happens if someone gets access to your actual device? Well, like, for example, I was using an ESP board to track costs that I was getting in Azure, and if someone actually got access to the physical device, there's no encryption on the device. And so someone could actually access my Azure account and start making charges if they wanted to. Do I think that that's going to happen at my personal house? Probably not. But if I'm running a business, those are questions that I have to be very aware of, and think very critically about how I'm implementing my edge devices, and what devices am I using and how am I encrypting data on the device.
Yeah, I get a little bit nervous about going back to the data side of things, depending on where you're accessing the data from, to being able to ensure that it's actually all valid and useful. Downloading data sets that you can get right now, you can go on GitHub and you can find huge data sets that people have collected of images of fires. If you're trying to train a camera to identify a forest fire or house fires. And there's if you're in something where there's millions of images, it's sometimes tricky to go through and just to be sure that everything in there is legitimately useful data to train the model with. And then from the publishing side, and this one's just not as maybe not as universally applicable, but also, it's always important when we're publishing a magazine that all of the images that we have permissions to use them. And is the data that you're using, is that all? If you are using a pre-built data set, is that proprietary information, or is it something that's been scraped from somewhere else? But that doesn't, if you're building your own data sets and you're training your own models, those things don't matter as much.
It's the image search problem times a billion. It's real. Yeah. So I think we have time for one more question. ML is currently widespread, but what skills do young folks need to develop to face today's challenges?
I think the most important one is your confidence, because they should feel that I can master that. And of course, they will gain all the skill sets along the way to train themselves to really face the problems. But the problems can vary as well. As we talking to a lot of industries, it's for education, you need to worry about the safety. If it's for like transportations, for securities, all kinds of real life issues. But I think the good thing today for machine learning is that the students don't need to deal with everything from hardware to software to machine learning. They might just need to train these types of devices as long as the device maker is opening up. So they can just train it according to their usage and put their special sources and either for their own goods or share it to other solutions. I think the confidence is a start. And by all the efforts, we should endorse that and to boost their know-hows and get familiar with tiny.
Oh, I love that so much. Thank you.
Yeah, I like that a lot.
I have a very technical, geeky response to that one, which is around ML ops. I think there's so much focus today on the model aspect and building this model to detect this and that. What often a lot of people forget is that you got to understand the full pipeline that's actually needed to go from the data collection part, some of which we already talked about, to the actual deployment and management aspects. I think there's so much emphasis in courses and everything in just a very small, important part, but a very small part of that big workflow that you have. And I think that's really what I think is extremely important.
Awesome. Yeah, totally. Mike, do you want to add anything?
My thoughts on it. I really liked, the way that Eric put it. The confidence aspect. If you can read, you can figure this out. It's all there at this point for you to follow along with. But if you want to know just someone like the specific technical things, you want to understand microcontrollers and sensors. You want to understand how to interface with them. You want to have some understanding of programming, or at least how to jump into the open source community and have them help you with it. But beyond that, it's all really right there at this point.
Totally. Yeah, along those lines, learning how to learn, design thinking, and the scientific method. I think that those three things are kind of three key skills that you can apply to pretty much anything. And also confidence and resilience. And I think learning to find joy in the world is really important, because every job is going to be hard. It doesn't matter what you do. There are different challenges. We're done at 9, right? AM PST?
Yes.
Okay, so I think that's time. We're slightly over 3 minutes. So thanks everybody that hung out. Are y'all okay to, I guess we could try one more question if y'all are okay to stay till 9:05.
Sure.
Okay, one more, last one. What do you think of on-device training / adaptive models? That does not seem possible for neural networks.
I think it's getting possible, because maybe we don't look at complex problems. We start from simpler data sets, but on more powerful edge devices. Then we move on to start with that kind of things. And I think it's also critical, if you have on-device trainings, you can obsolete the problem versus all the solutions. And it will get there. Let's look at all the silicons coming out, all the algorithms simplified for that, like all the binary neural networks. You can just use a free, simple microcontrollers if you just want to train for a temperature change. So I think it's totally durable, and we'll get better. Maybe in the future, we can train complex models on very simple devices.
Yeah, I agree. Certainly, I think it's getting possible. And I think one of the interesting things is that I think definitely should be a takeaway from this is don't go bonkers on just deep learning, right? Machine learning is pretty big, right? So one of the things when you want adaptability and flexibility is that you want to focus on machine learning, not just deep learning, which is a subset of the machine learning. So statistical methods, decision trees, and so forth are actually very easy to update on the fly. And so there's an entire class of algorithms that can be adapted on the fly, not complex neural networks alone. So
That's a great point. I think a lot of it, I don't know if it's so much as that it's the neural network structure. I think it's the model size. And probably part of that has to do with the underlying mathematics. But I think really the constraints when we are thinking of embedded ML is the amount of memory on the device. And that's, models are getting smaller and devices are getting larger, memory wise, not physically wise. Chips are getting smaller, but the size is getting bigger. What does that mean? So I think the technology is still improving, but there are kind of ways that you can hack that, right? Like if you do decide you want to connect to the cloud, you can do continuous learning that way, by uploading photos and kind of setting up a program to train a model with new photos and then putting it back down. There's also a thing called federated learning. We probably don't have time to get into that, but if you're curious, check it out. It's super cool. Thank you so much, everybody. Thank you, audience, for asking great questions. I know that we didn't have time to get to everybody, but you're welcome to reach out to folks and ask questions directly. I know that there was a question about Copilot, and I have opinions about that. So feel free to reach out to folks. Thank you so much to the brilliant and fabulous panelists, Professor Vijay Reddy, Mike Sinisi, and Eric Pan. I apologize if I mispronounced anybody's name. Any last thoughts that you want to share before we say goodbye?
Just want to say thanks to you guys as well, and to Edge Impulse for having us here. This is it's been really a lot of fun.
Indeed. And thank you, Jen, for gathering us all together and making sure we actually show up on the call and actually give useful answers.
And thank you very much. And we are very proud about this. It's inspire more like future AI users.
Yeah. Oh, one plug. If people are working on any projects in this space and they want to let Make Magazine know about them, reach out to me, mike@make.co. That's my email address.
That's awesome. And yeah, thank you, Edge Impulse, for hosting and for providing the forum. Awesome. Woohoo! All right, go forth and have a beautiful Friday, everybody. Bye.
See you, everyone. Are we off the grid yet?
How do you leave?
Okay, anyway, good job.
Yeah, great job.